So let us start with a problem like this. A charged particle with charge q and mass m is released from origin with zero initial velocity in a region of uniform electric and magnetic field. If the field E is acting along x-axis, field E is acting along x-axis and B along y-axis, such that it is given E equal to E0 into I and B equal to B0 into J. Discuss the motion of the charged particle. Okay. E equal to E0I and B equal to B0J given. No velocity, initial velocity is given. You have to discuss the motion of the charged particle. Here both the fields are there. They are neither parallel nor coincident. Field along x-axis exists, magnetic field along, electric field along x-axis, magnetic field along y-axis exists. Here problem is to find obviously the velocity as well as the position of the charged particle. Okay, we'll find both position and velocity of the charged particle. So this is the problem which is bit mathematical, because cross product will be involved that you can predict. At the same time, we need a solution of this equation d square x by dt square equal to minus omega square x. Most of you did in class 11 this solution. The solution to this equation can be taken as x equal to a cos omega t plus b sin omega t. If you say that I did not study it, I don't know it, I'll tell you to verify. It's a second order derivative problem. All of you know this much mathematics. When we find derivative twice, we get this thing back. Or one can write the solution in this form also. X is equal to a cos omega t plus epsilon or delta, whatever you see. Okay. So this A and E will be determined from the given initial condition. Here if I tell you the initial condition is this only, at time t equal to 0, it is released at the origin of the three-dimensional coordinate system. On it, the electric field is directed along x-axis, the magnetic field directed along y-axis. So if the magnetic field is directed along y-axis, then if you are going to find the magnetic Lorentz force here, first you write electric Lorentz force. The value of electric Lorentz force is going to be Q into E0 if charge is Q. And magnetic Lorentz force Fm equal to, here I am telling the force will be along x-axis only. If vectorial you can write Fe will be Q E0 I cap. Fm will be what? This will be Q V cross B. This is a problem here. What B and what V? V is not given. So which B are you going to consider? My argument is that Initially, charged particle was not moving. At t equal to 0, its position 0, velocity 0, everything 0. But electric field, as it is acting along x-axis, with time, the charged particle will go along x-axis, but as soon as it is in motion, the magnetic field comes into effect. It will try to deviate it, isn't it? So velocity we are taking in this manner. Let v equal to, due to magnetic field is directed along y-axis. The strategy you have to fix up first. Magnetic field forever directed along y-axis. So it will compel the charged particle to describe circular path in the xz plane only. Okay? At least initially it will try to do so, because electric field is acting. Motion will not be uniform that manner. It is a critical case here. Okay? But it is sure that as soon as it starts its motion along x-axis due to electric field, the magnetic field start deviating it. The magnetic field will try to compel it to move in the xz plane. So this is the catch. We'll assume that velocity will lie in the xz plane only, not along the direction of y, because this deviation will be in the xz plane. The particle has force acting on along x-axis only. So let us start the problem this manner. Let the problem I am starting by assuming that let v equal to vxi plus vzk. Okay? Because the particle will lie in the xz plane, unit vector in this direction is I cap, in this direction it is k cap. So v we can assume this manner, vxi plus vzk. So magnetic Lorentz force at any instant, if we want to find, we can write this v as vxi plus vzk cross b, b0j. Okay, so Fm going to be q vx b0 I cross j will be what? K plus vz b0 k cross j. K cross j is going to be minus I. Okay, so you got magnetic Lorentz force, you got electric Lorentz force. Let us compare with the net force by writing F equal to Fe plus Fm. This will give us Q E0 I cap, Q Vx B0 K cap minus this Q lies here also, Q is common, minus Q Vz B0 I cap. Okay, so this you write Q into E0 minus I cap Q into Vx V0 K cap. Okay, and this force, then this force you can write F is equal to Fe plus Fm, that you can write that acceleration vector you write. Acceleration vector is force vector by mass. So there it will be Q by M common E0 minus B0 Vz I cap plus Vx V0 K cap. Okay. So this acceleration vector you write only I and K component there. So you can write AXI plus AZK equal to Q by M V0 Vz I cap plus this Q won't be there by mistake plus Vx V0 K cap. Now if we compare two sides, comparing we get AX is Q by M E0 minus and AZ equal to Q by M, the same expression. So you take this one as number 1 and this one as number 2. We have to get Vx, Vz, we have to get x and z coordinate also. And it is quite obvious that it is not going to be in accordance to the formula when B and E was in the same direction that x and z you can get. That formula will not help because the charge particle is taken by electric field along x-axis simultaneously. Even I don't have the right to write the expression this manner. This drawing I can't do because circular path it will not do. If it does circular path, then it is nice. But here it is not possible. Nice means we can get the x and z coordinate very fast. But here electric field also will take. So let us do some mathematical work. I told you the problem is a bit mathematical here. Let us see how to get it. This expression, when we differentiate here, differentiating with respect to t. Why differentiating, that you must understand. dAx by dt, E0 is a constant. Why have I differentiated, you understand? Because this thing going to be Q V0 by M into AZ. What is the advantage? dVz by dt is AZ because acceleration along Z axis. This implies dAx by dt is minus Q V0 by M into Q V0 by M Vx. And here what do you get? Ax is what? Ax dVx by dt. This is minus Q V0 by M whole square into Vx. So one can say that this thing is d square by dx is minus isn't it? So this is something like the differential equation you have started with. that is solution is a cos omega t. Can I write this one omega? Therefore, d square Vx by dt square, this is of course omega. See how mathematics helps to solve natural problem. Mathematics is, people say, most abstract, but it can explain the nature. Q B0 by M, BQ by M we got back here. So omega we can easily express here. But who told that that same expression will be getting here? It has come. So this is the beauty of mathematics, that d square Vx by dt square minus omega is there, and that into Vx, which is differential equation like simple harmonic motion. This you take as number 3. Solution to number 3 I will be listing here. If I do side by side, it will be easier. So if we solving number 3, we get Vx. Vx equal to a cos omega t plus delta or epsilon as you know. That's okay, I write epsilon because I have taken epsilon there. Epsilon is a constant. Now when t equal to 0, no velocity was there along x-axis. So this implies 0 equal to so you can write sign also. Better you go by sign because another negative sign otherwise will come. Go by sign. It can come cos also. You can take cos also. It doesn't matter. So this will be sine epsilon. Then sine epsilon will be equal to 0. This implies epsilon equal to 0. This Vx will be a sine omega t. Okay. Now, after getting the value of Vx, let us see whether we can get Vz or not. Can you get Vz? Vx we got. So Vx, if we substitute there, we can get Vz from there. Now, Az equal to Q by M B0 into Vx. A sine omega t. So this implies that Az is what? Az stands for, Az means acceleration along z axis. You can write this as okay. So if we integrate both sides, integrating Vz will be AQ B0 by M into plus the integration constant you take K. We can find the value of K also here when t equal to 0, along z axis also no velocity was there. 0 equal to minus by m omega cos 0 is 1 plus k. So k we got here. Therefore, Vz is going to be one minus. Now A I did not find. I will find it. Another thing, omega is BQ0 by m, no? Omega, value of omega is that. Here I got the same thing, BQ0 by m. So you can put it there. If we put, then it is going to be A into, since omega equal to, okay. Now, what is the value of A? A we did not find. Capital A we can find from here. I found epsilon only. I forgot to get the value of capital A, but capital A we are going to find. So Vx A sine omega t. Now Ax is A omega cos omega t. When t equal to 0, Ax was there. What is Ax? Initially, what is the value of Ax? That is Q0 by m. We put it there. Sure. So Ax going to be Q0 by m, isn't it? Because along x-axis force is Q0. So if I put there Q0 by m, A omega 1. A is coming 1. How it can be? 1 is not possible. You need to check it again. Whatever, I am keeping it A only. Will they check this? Vx is A sin omega t. Ax is A omega cos omega t. When t equal to 0, Ax is this thing. Because electric field only will be taking. So Q0 by m equal to A omega. Omega value is what? Oh, sorry. Omega has a value. Omega we got earlier. What is omega here? Check. The value of omega BQ by m. Isn't it? This is not 1 then. It's going to be a very interesting quantity there. BQ by m. So this is going to be E0 by B. A equal to E0 by B. B means B0, sorry. It's a very interesting thing. You know E0 by B0 ratio. Any idea you have? E0 by B0 is speed of light. No, not speed of light. What is E0 by B0 then? Yes, E0 by B0 is speed of light. That you can prove also. Okay, let me do it first, then I'm coming back. Bz is coming E0 by B0 1 minus cos omega t, and Vx is coming. I found Vx. Where is that? Vx is A sin omega t. that is E0 by B0 sine omega t. So here velocity along x-axis, now you can write E0 by B0 sine omega t. Vz is coming E0 by B0 1 minus cos omega t. Everything can be determined from here. Everything means the position. Bx stands for what? Dx by dt. Isn't it? So integrate, x will be plus k dashed, integration constant is k dashed, when t equal to 0, so k dash going to be 0 by b0 omega. So you can write the value of x, it is going to be see how fun is there. Every step is coming nicely. And z, from here if you write dz by dt equal to, and then if you integrate t minus sine omega t by omega, isn't it? 0 by b0 t minus sine omega t by omega plus k double dashed. Again the same manner, when t equal to 0, z equal to 0. This implies 0, all are 0, k double dashed. So therefore, z is coming to be with time fine. So z coordinate we got, x coordinate we got. What about y coordinate? It doesn't move along y-axis at all. What can I do? Because magnetic field is acting along y-axis. Magnetic field cannot take the particle along its own direction. Only electric field is taking. Magnetic field, what it can do? It can deflect. By deflecting it, it can give some x, z coordinate to it. But y coordinate, never. Okay?